Welcome back, everybody. Here comes a video on solving rational equations. Now, solving rational equations is at sometimes very simple and other times it can be a little bit challenging depending on what kind of denominators you're working with. So what we're going to do here is talk about two different styles. You have ones that are actually very easy like this when you just have two fractions that are equal to each other. You already know how to solve that one. I really even shouldn't need to tell you, but I will. But then you have some where you have more than one fraction on each side. Now to do those, there are two different ways. One way would be to just combine one side, which some people like to do. But in my opinion, the easiest method is to get a common denominator for the entire equation. So we have a 3, a 6, and a 1. So our common denominator is going to end up being 6. Because we can multiply this by 2, and we can multiply this one by 6, and we would end up with 2x plus x is equal to 12 for the numerator, but the easy part is you can now ignore the denominator. And then you just solve it. So 2x plus x is 3x is equal to 12, and then we have x is equal to 4. And you're done. Because once you have a common denominator, the only thing that matters is the top. Because the denominator has a different role. Now, the denominator does not have anything to worry about when they're numbers. In this next example, the one you actually already know how to solve, there's something you need to make a note of first. And that's the fact that x is not allowed to equal 0 or a negative 4. Why? Because your denominator is never allowed to be 0. So if you plug a 0 into this one, you have a 0 in the denominator. If you type a negative 4 or put a negative 4 into x here, negative 4 plus 4 is 0. So that would also give you 0 in the denominator. So we're going to solve it. And if x is equal to 0 or a negative 4, we are not allowed to include it in our solution. It's known as an extraneous solution. We'll talk about that more when we get to one of those examples. So why do you already know how to do this? It's because it just comes from a similarity geometry unit where you just have to cross multiply. So x times x is x squared. That's equal to 2x plus 8 after you multiply 2 to both terms. So you're just cross multiplying. So then you have x squared minus 2x minus 8 is equal to 0. You factor that, you have x minus 4 and an x plus 2 equals 0, so x is equal to a positive 4 and a negative 2. We check with what x is not allowed to be, and we are good to go. So x is equal to 4 and negative 2. So if you have two fractions, you can just cross multiply. If not, the easiest way is to just get a common denominator for the entire problem. Okay? So, next example here. If you want, you could just find a common denominator and just set it equal to 4 when you're done. So I'm showing you the other way now. So you would combine just this side, and that would give you 3 plus x squared. So you have x squared plus 3 all over x, and that's equal to 4 over 1. And now you just go cross multiply. So if you were to do that one step and then go cross multiply, you're kind of adding on an extra step. So that's why I just wanted to show you what you could do. So if you were to then cross multiply, you have x squared plus 3 is equal to 4x. X squared minus 4x plus 3 is equal to 0. So then we're going to have an x minus 3 and an x minus 1 equals 0. So x is equal to 3 and 1. And we would be done, because in the original, the only thing x was not allowed to equal was 0. Okay, now, like I said, that's the other way to do it. If you wanted to multiply this guy by x as well, we would have just canceled out the entire denominator and you'd have the exact same thing. So it's a little bit easier to do it by getting a denominator for the entire problem, but really you can do it any way you want. So this one, we factor anything that can be factored first. So difference of two squares, we have x plus 1 and x minus 1. So this 3 needs an x plus 1 and an x minus 1, which we know is x squared minus 1. And then this guy just needs the x minus 1. So sometimes you're going to have a lot more algebra involved. So this is one of those types of examples. But again, once you have it all set up, you can ignore the denominator. So we're going to have 4x plus 1 times x minus 1. That's equal to 12 plus 3 times x squared minus 1. That'll give us 4x squared minus 3x minus 1 is equal to 12 plus 3x squared minus 3. Start getting everything over on one side. 4x squared minus 3x squared is x squared. And we have a negative 3x and a negative 1. Subtract 9 back over to this side and we have a negative 10. That's all equal to 0. X minus 5 times x plus 2 equals 0. So x is equal to 5 and a negative 2. And you're done, because in the beginning, x was not allowed to equal the negative 1 or a positive 1. Okay, so just always make sure you go back and check with the original question. Okay? So we have 2 more examples. Why don't you pause the video and go give those 2 a try on your own, and we'll see how you did when you click play. So the first one, we have 2 fractions, so we can just cross multiply. X squared minus x is equal to 2x minus 2. So we have x squared minus 3x plus 2 equals 0. So we have an x minus 2 and an x minus 1 equals 0. So x is equal to 2 and 1. But x is only equal to 2. And there is an extraneous solution of 1. Now, why is 1 extraneous? Because if you were to go back to the beginning, x is not allowed to equal 0 or a positive 1. And that's because I told you, whatever makes the denominator 0 is not allowed. So if you plug in a 1 here, 1 minus 1 is 0. If you plug in a 1 here, 1 minus 1 is 0. But if you plug in a 0 here, 0 minus 0 is also 0. So whatever makes the denominator 0 is not allowed. Okay? And then the second example that you had to do, you should have multiplied this guy by an x minus 2. That gets rid of your denominator. And you end up with 5x is equal to 7x minus 14 plus 10. And that's just going to give us a negative 2x is equal to a negative 4. So x is equal to 2. And if you were to go back and look, x is not allowed to equal 2 because that would create a 0 in the denominator. So this is an example of no solution with an extraneous solution of 2. Okay, so x is not allowed to equal 2 here. That was the only thing we got, so he's extraneous. Okay, so always make sure you check the denominator. That's it for this video. This is Longo and I'm out. See you, bye.